In this video, I'm going to talk about one very specific topic, sustainability. And more specifically, I'm going to focus on the relationship between, on the one hand, sustainability and on the other hand, artificial intelligence. So I'm not going to talk about sustainability and technology in general, just AI and sustainability. There are many systematic reviews. Also, when we focus on normative ethics of AI. So a systematic review is a paper that gives an overview or a summary of all the academic work that has been done and published on one very specific topic, for example, normative ethics of AI. And one of them has been published in 2022. And it concludes that in many of the guidelines, many of the papers, many of the documents on normative issues in the context of artificial intelligence, there's a focus on fairness, accountability, privacy, etc. But there is also a gap in the literature. Not that many papers, not that many documents or guidelines are focusing on the ecological cost of training and using artificial intelligence. And that seems to be relevant. That seems to be morally relevant. Not focusing on ecological cost, not focusing on sustainability seems to be an issue, seems to be a moral issue. And why? Well, in general, people tend to say, well, there are at least two justifications for concluding that an environmental topic is also a moral topic, has some moral relevance. And there are two justifications. One of them is more deontological in nature. It says that environmental topics are as such relevant, right? So we should focus on water because water itself has a moral status. And that is different from a second, more consequentialist notion or justification for the moral relevance of an environmental topic. A consequentialist notion says, well, by definition, that we have to look at the consequences, that we have to look at the effects. So focusing on water, a forest, for example, or another environmental entity is not as such relevant. It's only irrelevant in a moral sense when it has effects, when it has morally good or morally bad effects on other entities, for example, human animals or animals that are not human. So we could say from a more deontological issue, water is as such morally relevant, but for a more consequentialist notion of ethics, you could say, well, we shouldn't focus on water as such, we should focus on water because of the moral consequences it has on other things. And it's this more second consequentialist notion that I'm going to take into account in this video on sustainability and AI. So what is the relationship between sustainability and artificial intelligence? Well, a lot of people talk about artificial intelligence in terms of, well, it's in the cloud. Well, it's in the cloud, it's there, right? And in a way that's, of course, we can understand why people are using this kind of notion, but at the same time, it's misleading. AI is not in the cloud, it's embedded in material, in metals, in minerals, in hardware, in computers, right? We need a lot of material structure in order to train an AI system. We need minerals, metals, and graphics processing units. And all these minerals, for example, or all these metals, they need to be mined. We need to find them at places, for example, at Silver Peak in the Nevada desert in the United States, where we have to do some mining, right? And mining minerals and metals goes often, in many cases, hand in hand with toxic mud that we'll find. Well, if you, for example, Google a picture from Silver Peak in the Nevada desert in the United States, then you will see on this picture black spots. Well, this is toxic mud, a substance that is by definition undesirable for organic entities, for animals, for non-human animals, or human animals, for plants, forests, and other organic entities. So that's one thing. So that's one thing about the relationship between AI and sustainability. But there's something else. Well, if we train an AI system, if we train a model, that's of course not based upon one computer. We need a lot of computers. And all of these computers are collected in big buildings, very big buildings. We call them data centers. And probably the biggest data center in the world is located in China. It's called the Telecom Inner Mongolia Information Park. It's about 1 million square meters big. And there are many data centers in the world. The rough estimation is that we have about 10,000 data centers worldwide. Some of them are owned by very big tech companies such as Microsoft and Google. Others are owned and used by other companies. So we do have a lot of data centers, and why is that relevant? Well, if you have a data center, then you have a building full of computers, full of chips, full of minerals, full of hardware. And if you're training an AI system, then it means that the temperature in that building will increase. But a very high temperature is of course undesirable for a computer, right? It's undesirable, so what we need is air conditioning. But we know that air conditioning asks a lot of water. So there is a lot of water that is needed in order to train an AI model. One thing is water, a second thing is electricity. There's a lot of electricity that is needed. So data from the International Energy Agency says that, well, in 2022, there was about 460 terawatt hours electricity that was needed in order to run all the data centers in the world. That's about 2 to 3% of the global consumption of electricity. And the rough estimation is that around 2060, 2070, we'll need about 1,000 terawatt hours of electricity worldwide to run all the data centers. And some people will say, well, this is relevant for financial reasons, this is relevant for more logistical reasons, but there is probably another more relevant reason why we should focus on the energy consumption. It's about greenhouse gases emissions, right? If you focus on one system, on one artificial intelligence system, GPT-3, well, we know from research that training this model asked about or went hand in hand with about 500 tons of CO2 emissions, right? That's equivalent to the annual CO2 emissions of 110 cars or 60 US households for 1 year. So that would take about 8 to 900 trees to offset these emissions. This was about the training phase, right? And we see that there are a lot of undesirable things happening when we are training an AI system in an environmental sense, right? But by definition, it's possible that within a couple of years, we will be able to train an AI system without greenhouse gas emissions. And it's going to be the case, right? A lot of companies are developing systems in a way that is climate friendly, right? That is desirable in an environmental sense, right? That's about the training phase. But we should distinguish that training phase from the user's phase, in which we use AI in order to realize this or that specific purpose. Well, if we are able at some point to train an AI system without the emission of greenhouse gases, we should keep in mind that the biggest companies in the world, the biggest big tech companies in the world, I'm talking about Google and Amazon and Microsoft, for example, that they do have very specific divisions in which they train an AI system in order to do just one thing, to detect in a very fast way, in a very efficient way, fossil fuels. And these trained systems will at some point, of course, be bought by ExxonMobil and Total. So even if we are able to train these systems in a good way, they're still going to be used in a bad way, at least in an environmental sense. They could still be used in a way that is undesirable for environmental goals. And that's something that we should take into account when we have to think about the normative ethics of artificial intelligence, which is more than just about bias, privacy, and responsibility.